Welcome to Get Your FRQ On. This question is from 2012. It is question 3, and it is not calculator active. In the question stem, we have a function f of t, which consists of 3 line segments and a semicircle. The function is defined on the closed interval from -4 to +3. And we also have a second function, g of x, which is defined as the definite integral from 1 to x of f of t dt. In part A of this question, we are asked to find g of 2 and g of -2. G of 2, by definition, is just the definite integral from 1 to 2 of f of t dt, which, based on the graph provided, we can calculate it is -1/2 times +1/2, which is -1/4. Likewise, g of -2 is defined as the definite integral from 1 to -2 of f of t dt, which would be the opposite of, using properties of integrals, -pi/2 plus 3/2. If I take the opposite of that, I'm going to get pi minus 3 all over 2. In part B of this question, we are asked to find the value of g prime of -3 and g double prime of -3, or state that it doesn't exist. Since g of x is defined as the definite integral from 1 to x of f of t dt, g prime of x is just going to be f of x, and g double prime of x will just be f prime of x. So if I want the value of g prime of 3, g prime of 3 is, by definition, f of -3. We can read that right off the graph. F of -3 is +2. Likewise, if I want g double prime at -3, I'm just looking for f prime at -3, which, if I do the calculations from the graph, f prime of -3 is +1. In part C of this question, we are asked to determine at which x value or values g has a horizontal tangent line, and to determine whether these are minima, maxima, or neither, with a justification. So g of x is going to have a horizontal tangent line when its derivative is 0, but the derivative of g of x is just f of x. So what we're really looking for is places on the graph where f of x is equal to 0, which, when we look at the graph, we can tell that based on the graph of f of x that's provided to us, f of x equals 0 at x equals 1 and x equals -1. Okay, so now the question is, are these maximums, minimums, neither, and how do we know? Well, if we start at x equals 1, we note that f of 1 is equal to 0, but the graph of f does not change sign at f of 1, and therefore g of x will not have a minimum or a maximum there. Remember, in order for it to be a maximum, f of x would have to change from positive to negative. In order for it to be a minimum, f of x would have to change from negative to positive there, but it doesn't do that, so it's neither a minimum nor a maximum, it's neither. And then moving along to x equals -1, at x equals -1, f of -1 is equal to 0, and it does change sign from positive to negative, which indicates that g of x would have a maximum there at x equals -1. In part D of this question, we are considering the open interval from -4 to 3. And we are asked to find all the x values for which g has an inflection point, and to provide justification. So the function g is going to have an inflection point when its second derivative changes sign. And that it could be 0 there, or it could just change sign because of a discontinuity or something like that. It's not necessary that g double prime is equal to 0. Well, again, g double prime of x is equal to f prime of x, and we have the graph of f of x, so we can just figure out graphically where does the slope of the tangent line to f of x change sign from positive to negative or negative to positive. So looking at the graph provided, f prime of x changes sign at x equals negative 2, x equals 0, and x equals 1.